Since my project deals not only with priming but language, here's a brief lesson on language and the brain. This is your brain. Well, sort of. Okay, so as we all know, there are two hemispheres of the brain, the left and right. This is the left hemisphere. The brain is made up of 4 lobes: frontal, occipital, temporal, and parietal. Language is housed in the left hemisphere, and actually, a relatively small part of the cortex is used in language processing. Okay, so this is the Sylvian fissure right here. This area around it is where language processing takes place, and the Sylvian fissure is a deep groove that runs about parallel from your eye to the middle of your ear. The 2 most important parts of the brain when we're talking about language is Wernicke's area, right here in the green, and Broca's area in the purple. In 1861, Pierre-Paul Broca, who is a neuroanatomist and surgeon, published the first papers on language and the brain. His research, like Wernicke, focused around damage to the brain, and that is really how we know a lot about how language in the brain works. It's because of damage, which is called aphasia, and aphasia is a disturbance in language production because of damage to the brain. Broca was the first to say that damage to a specific area of the brain inhibits speech production, which is Broca's area. Now, Broca's area is right in front of what we call the facial motor cortex, which is the parts of the brain that processes the muscles that you use to actually speak. So your cheek muscles, your mouth muscles, all that is housed right behind Broca's area. Broca's aphasia makes it difficult or impossible to produce speech, but people with Broca's aphasia can understand what you say, and they can also write out what they want to say. They just can't speak it. Cardinal Wernicke was only 26 when he published his first paper on aphasias. In 1874, he described a site outside of Broca's area that, when damaged, impedes language also. Now, people with Wernicke's aphasia can speak, but it doesn't always make sense. So if I wanted to say, the Google Science Fair is totally awesome, and I had Wernicke's aphasia, I would say, frog, monk, jump, monkey, baby. That's how it worked. In my head, I would have been saying the Google Science Fair is totally awesome, but that's what would have come out of my mouth, and I would not understand that you cannot understand me. People with Wernicke's aphasia can speak, but they have trouble finding the right words, and this also affects their written language as well. So people with Wernicke's aphasia can speak, but they have trouble finding the right words. So if I had Wernicke's aphasia and I was trying to say knife, I would say the thing we use for cutting. And they also have trouble understanding written and spoken words. So this is what happens when language is produced in the brain. So if you hear a word, the word goes into the auditory cortex, which is housed in the temporal lobe, and then it goes into Wernicke's area. If the word is in your head and you're going to speak it, it moves from Wernicke's area to Broca's area to the facial motor area, which we talked about earlier. Now, when a word is read, like the participants in my study had to do, the word goes from the occipital cortex, which houses the visual parts of the brain, to a part of the brain called the angular gyrus, and then it moves into Wernicke's area. Reading relies on areas of the brain that was actually first evolved to process vision and spoken language, and that was a bit about the brain.